So I'm watching my dog make a fort of some kind out of the blankets and the pillows. It's next to the couch. Weird. I thought my house would be really super clean. It's not. I thought I would have been doing all this wonderful spring cleaning in the house. I haven't. I thought I would at least organize some things that aren't organized. Nope. Haven't done that either. So what have I been doing? Netflix. I started a new series, but I'm running out of options. So I'm going to need some help on that. He's building a fort. This is weird. Rowan, what are you doing? Weird dog. All right, here we go, guys. 10.5. This one's today specifically about reading scientific notation, and I abbreviate it as Sci-Not. So when you see that, just know that I'm talking about scientific notation. Scientific notation is a way to write really, 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 really small numbers and really, 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 really big numbers in a condensed form. The form that it takes is C times 10 to the n power. C has to be a factor that's less than 10 and greater than or equal to 1. And the way that we write that, so it's a factor, this C has to be less than 10, and this C all has to be greater than or equal to 1. So basically you're looking at a number that's greater than 1 and 1, but also less than 10. Now, your n, your power, is an integer. So it can be positives, negatives, or 0. And so scientific notation, it's just a way to write these big numbers and small numbers really short, so you don't have to write out all those zeros to show how small it is. This is just a condensed form. Now, those of you guys who are going to be science majors or math majors, you will be using this quite a bit, and actually in your chemistry classes and your organic chemistries and all that kind of stuff, you will be using scientific notation quite a bit. So this is something you will keep and use for your later classes in college. So today we're just going to work with some basics of scientific notation. Example 1, it's asking us just to identify if the number is in scientific notation. So is it in Sci-Not? And explain. All right, so we have 5.9 times 10 to the negative 6 power. Now, when you look at this, you want to look at your factor C. Is this number less than 10 and greater than or equal to 1? And yes, it is. But then you also have to look at this power to make sure it's a positive, a negative, or a 0. And it is. So therefore, yes, it is in scientific notation. And so when you have to write out your explanation, it's kind of lengthy. So you go factor is, and you could even say, you could write out the words less than 10. And you have to make sure you put this other part, greater than or equal to 1. And here's your other part. Your power is an integer. So your explanation is kind of lengthy because you do have to talk about your factor. There it is. And you have to talk about the fact that your power is an integer. So that's what your answer would look like. Just explaining why it is not in scientific notation. So do another one, 0.67 times 10 to the third. So you want to look at this number. You gotta ask yourself, is it, right here, is it less than 10 and greater than or equal to 1? No, it's not. So since it is not, you don't have to worry about your power, because if one part throws it off, then the whole thing is not in scientific notation. Not in Sci-Not. Factor is less than 1. And that's all you would have to write for that one. When we ask about, pardon me, when we ask about other numbers, don't let your factors get thrown off, because you can have something like 2.5732 times 10 to the negative 16. And so what you're looking at, even though this has all these decimal places in your number, it doesn't matter. As long as this guy right here, as long as the number that is to the left of your decimal is less than 10 and greater than or equal to 1, then it doesn't matter how many decimal places you have. You can have, 1 or 2 or none or 22 decimal places. It does not matter. And this whole number is in scientific notation because this factor is less than 10, greater than or equal to 1, and your power right here is an integer. Okay? All right, so when we write numbers in scientific notation, the power, n, tells you two things. It tells you the direction to move and how many places it moves. So we want to pay attention to this guy. Our n right here does two things, and I will write that out, and I will have it on a separate sheet of paper, and I will upload that today, the same thing as I have your video uploaded today under materials in your Google Classroom. So example 2 is writing numbers. Sorry, I got a frog in my throat. Right, in standard form. So standard form is just your basic form that you guys are used to, like 1,322, 16, 10, 1, that kind of a thing. So we're going to take this condensed form, the scientific notation, and we're going to write it in numbers that we're used to. So we have 3.22 times 10 to the negative 4. Now with our negative exponents, you guys knew that numbers got smaller, but they did not turn negative. So what happens when you have a negative power, that means your factor has to get smaller. If your power is positive, that means your factor gets larger. So when you have a negative power, that means you're going to move your decimal to the left, because that means that 3.22 will then become smaller. If your power is positive, you're going to move your decimal to the right, and that's how you get your factor to be positive. So when we do this, the sign of the power tells you which way to move, and the actual number itself tells you how many times. So I have 3.22, and since this is negative, it's going to get smaller. So I'm going to move my decimal to the left 4 times. So left 4 times. So 1, 2, 3, 4. And you're going to fill those little, I call them something else, but I'm not going to right now. You're going to fill these in with zeros. So then you have 0.000322. And that is how you write your numbers that are in scientific notation into standard form. So the negative made your factor go smaller, and it also tells you how many times to move it. And like I said, I will write this all out for you guys. So let's do another one. 7.16 times 10 to the, 5th power. So since 5 is positive, that tells you that your factor 7.16 is going to get larger. So you're going to move your decimal to the right. And you're going to move it right 5 times. So when I do this, you write your factor, whatever it is. Don't drop any of the decimals. Don't drop anything. Okay? Now you're going to move 5 to the right. So there's 1, 2, 3, 4, 5. Fill them in with zeros. And when you rewrite this, don't leave your answer like that. It's ugly. It doesn't look good. So you're going to rewrite it. And you need to have your commas. So remember, go from the right. So 7.16 times 10 to the 5th in standard form is 716,000. All right, let's do a couple more. Hopefully you guys have been doing okay. Last couple of days I've been quite a little batty. I just kind of want to get out and go do stuff. But I have to be smart. 16 times 10 to the 3rd. Can I write that in standard notation? Well, first of all, standard form, sorry. First of all, this isn't in scientific notation, so I can't even do anything with this problem. So this can't do that. Now what I can do 1.6. Okay? So remember, this number, your factor, has to be less than 10 in order to do anything with scientific notation. But you can do that. So 1.6 times 10 to the negative 3. Your negative sign tells you you're going to go to the left and 3 times. So I'm going to start at 1.6, go 1, 2, 3. So 0.0016. And they can do numbers like this. It's kind of tricky because they're trying to get you to really think about what your factor is. So we go, let's just go, I don't know, 8 times 10 to the second. Well, let's actually think about this a little bit. They want you to write this in standard form. Well, what is 10 to the second power? Well, it's 10 times 10, which is 100. So you're actually doing 8 times 100, which is 800. But in scientific notation, we're going to move this twice to the right since it's positive. So we start out with 8, but you have to know where your decimal is. Is it before 8 or after 8? And hopefully you said after 8. So you're going to put the decimal here and move it twice and fill it in. And you have your 800. So scientific notation does allow you to write these really small and really big numbers in condensed form, but also don't forget what you're doing. These powers of 10 are always going to be a base 10 number. 1, 10, 100, 1,000, 10,000, 100,000, on and on and on. So you can also redo this into a base 10 problem. So just kind of get your mind wrapped around what these actual problems are doing and what scientific notation is allowing you to do without having to write out all these zeros. All right. Here we go. I don't have many examples today, which is good. Example 3. All right, this one says we're going to compare. Now, there's a couple ways you can do this. When you compare scientific notation, until you kind of get the hang of scientific notation and what you're doing and how you're doing it, you can always write numbers that are in scientific notation into standard form, and then you can also write your numbers that are in standard form into scientific notation. It doesn't really matter. But if they ask you to leave your answer in scientific notation, then you need to make sure you write it with the C times 10 to the n power. If they ask you to write in standard form, then you're writing something like 342, 1,719, something like that. All right, so example 3 says an object with a lesser density than water will float. An object with a greater density than water will sink. Use each given density in kilograms per cubic meter to explain what happens when you place a brick and an apple in water. Have you guys bobbed for apples? What do you think is going to happen to the brick? That whole fat floats, muscle sinks? Yeah, I'm going to probably float. Some of you guys will probably sink really fast. All right, so here we go. Water. And you could just look at this in the book. It's example 3. Water has a density of 1.0 times 10 to the third. And a brick. Hopefully you guys said the brick is going to sink just because you guys are in 8th grade and hopefully your common sense is a little bit more common. 1.84 times 10 to the third. Can you see that? 10 to the third. And then apple. Kind of like how we bought for apples in our relays. Oh, we were supposed to have one last Friday. I'm kind of bummed. Times 10 to the second. So there's your densities of your 3. All right. And that is 10 to the second. So what you can do, you can write these all in standard form. I keep saying standard notation, but it's standard form. Or you can just compare them like here. So what I'm going to do is I'm going to take these and I'm going to put them in standard form first. So water, 1.0. Now 3, since it's positive, that means your factor is going to get larger. So we're going to move the decimal to the right 3 times. 1, 2, 3. Fill it in. So we have 1,000. We're going to compare that number. Do the same thing with brick. 1.84. Now it's power of 3 as well. Since these guys have the same powers, what you can do is then you can compare 1.0 and 1.84. Which one's larger? Well, 1.84 is, so that tells you the brick is going to be denser. So we're going to still move it into standard form. So we have 1, 2, fill it in with a 0. And we have 1,840. Forgot my comma over here. And then with an apple. Well, this power is less. So that tells you you're going to only increase this by a base 10 number of 100. This is increasing by a base 10 of 1,000. So this right here tells you it's already going to be less dense because your power is smaller than your power over here. But like I said, it takes a little bit to get used to that. So in the meantime, what you could do is just move them into standard form like I've been doing. So 6.41 twice to the right. And you actually don't have to fill that in because there's nothing to fill in. So you are comparing 1,000, 1,840, and 641. And it says compare the densities by writing each in standard form. All right, so we're going to go for the less dense, or also known as the smallest number. So apple comes first, and that's 641. And then water, and that's 1,000. And then brick, I don't know why, but now I'm starting saying brick house in my mind, 1,840. And there is your answer. And I kept what the items were with it to let you know. So that tells you the apple is less dense than water and the brick is more dense than water. The apple is obviously less dense than the brick itself. So when you're doing scientific notation, remember the sign tells you which way to go. Positive goes to the right, negative goes to the left, and the number itself without the sign tells you how many times to move. So if the number is 12 and it's positive, you're going to go 12 to the right. If it said negative 12, you're going to go 12 to the left. If it says 0, ooh, it's something to 0 power. I can wait. 1. Something to 0 power is 1. So what you're actually doing is a factor times 10 to the 0 power is actually just a factor times 1. So it's kind of a little tricky, and I don't think you guys are going to see them in your homework for tonight. But just keep that, in your little back pocket there for your nuggets of knowledge. I think I'm good. That last example is really only for the last problem. That's 27. Please continue to do your homework like you're supposed to. Write the problem, do the work underneath, and then circle the answer, please. And I will be back tomorrow for 10.6. We're going to do a little bit more with scientific notation. 10.6 is actually writing numbers in scientific notation. So today what we did, we went from standard form, right? No, we went from scientific notation form into standard form. And so for tomorrow, we're going to go from standard form into scientific notation. So we did this today, and then tomorrow we're going to go back up. We're going to kind of make a complete circle of that. All right, extra credit question. I need new ideas on what to watch on Netflix or any other show. So send me a reminder. Let me know what you think. Bye, guys.